Have you ever thought about the difference between a perfectly organized filing cabinet and, say, a massive, chaotic flood? Well, that's pretty much the story of data today. We're going to dive into these two completely different worlds: the neat, predictable universe of traditional databases and the powerful, messy, absolutely enormous world of big data. All right, let's get into it.
For the longest time, this is what data meant to us. It was a spreadsheet. It was a nice table with neat little rows and columns. Everything had its place. It was predictable, it was manageable, and honestly, it was a little bit boring. This was the gold standard for how we thought about information. But then, something happened. The world started generating all this information that, well, it just wouldn't fit into our neat little boxes anymore. Suddenly, the old rules just didn't apply. So what do you do when the flood of information is way too big for the filing cabinet?
To really get the revolution that happened, we first have to understand the old way of doing things. So let's start with that digital filing cabinet, the relational database. For over half a century, this was the undisputed king of organizing information.
So what is it exactly? Well, a relational database, which was first dreamed up way back in 1970 by a guy named Dr. E.F. Codd, is basically a system for storing information in these interconnected tables. It organizes everything into really clear rows and columns. Just think of it as the ultimate organizational tool, where every single piece of data has a very specific, defined home. And here's where we can demystify some of the jargon. See those columns, the ones labeled name and salary? In database speak, those are called attributes. And each row, like the one for Einstein, that's called a tuple. It's really just a fancy way of saying a single, complete record. Simple, right? And working with these things is a very deliberate, step-by-step process. First, you have to design the blueprint, what's called a schema. Then you build the empty tables. Then you can load your clean data in. Only after all that can you ask it questions or query it and make changes. It's methodical, it's predictable, and it works beautifully for a certain kind of data. But then, the world changed. The internet, social media, smartphones. Suddenly, that calm, structured world of the database was completely overwhelmed. This is the moment data exploded, and a whole new field was born just to deal with the chaos: big data. So what is big data? At its core, it's a field dedicated to handling data that is just too big, too fast, or too complex for the old-school databases to handle. The old tools just broke under the strain. So big data is all about building new tools to capture, store, and analyze this crazy new kind of information. So how in the world do we wrap our heads around this data deluge? Well, the classic way is through a framework known as the 3 V's. They perfectly describe the core challenges of this new world.
The first V is volume. And we're not talking about just a little more data here. We are talking about an immense, almost unimaginable scale of information that absolutely dwarfs anything a database was ever designed to hold.
And this chart just illustrates it perfectly. In 2010, all of humanity generated about 2 zettabytes of data. Okay? A decade later, 64. And by 2025, that's forecast to be 181 zettabytes. That's not just growth. That is a vertical, exponential explosion of information.
The second V is variety, and this is so crucial. The problem isn't just the sheer size of the data, it's the unruly, messy complexity of it. Most of the data being created today is unstructured. It doesn't want to live in a neat little table.
And this variety goes way beyond simple tables. We're talking about everything from the text of web pages and product reviews to the complex graph data from social networks showing who knows who, all the way to the GPS location data streaming from our phones. It is a chaotic, beautiful mix of formats. And the third V is velocity. This is all about the unrelenting speed at which this data is being created and delivered. We're not talking about analyzing last month's sales report anymore. We are talking about analyzing what is happening right now, this very second.
This has some incredible real-world applications. I mean, think about getting a coupon on your phone the second you walk by a store, or healthcare sensors that can alert a doctor to a problem instantly. This is high-velocity data in action, letting us make decisions in real time.
But you know what? The story doesn't end with those 3 V's. As we've gotten better at handling the scale, speed, and shape of data, we've started to uncover these deeper, more human challenges.
The focus has really started to shift from just quantity to quality. It's great that we have this massive flood of data, but what if it's dirty? What if it's just plain wrong? The question of all is from, hey, is our system big enough, to, can we actually trust the answers it's giving us? This is often called the 4th V, veracity.
And the stakes for getting this right couldn't be higher. As this quote makes chillingly clear, bad data isn't just some small inconvenience. It leads to disastrous, real-world consequences, costing companies revenue, credibility, and even their customers.
And this problem is terrifyingly real. Just look at these numbers. 500,000 dead people with active Medicare cards, 21 million extra insurance numbers in the UK, and this is the most shocking one. Medical errors, often driven by bad data, contributing to potentially 250,000 deaths a year in the US alone. This is the real cost of ignoring data quality.
And this brings us to the final and honestly the most important V of all, value. Because after all that work, wrestling with the volume, taming the variety, keeping up with the velocity, and cleaning up the veracity, if you don't extract something valuable, what was the point? All that data is just expensive noise if it doesn't lead to a meaningful insight. So, we have these two very different worlds, right? The highly structured database on one hand and the massively scaled world of big data on the other. They seem like total opposites, but they're really just different tools aimed at the exact same fundamental goal, trying to make sense of information.
This final table really puts it all into perspective, side by side. Relational databases are all about structure, consistency, and organization, usually on a gigabyte scale. Big data is about finding insight and making predictions from varied, real-time zettabyte-scale information. It really is the filing cabinet versus the flood, and each one has its own very important purpose.
And that leaves us with the ultimate question for our time. With all this incredible power to collect and analyze information on a scale we've never seen before, are we actually getting closer to the truth? Are we finding more profound answers? Or are we just getting better at creating more and more sophisticated noise? It's definitely something to think about.